Hello everyone. In this video, I am going to explain a different CPU scheduling algorithm. So here we have a CPU scheduling. CPU scheduling is the mechanism an operating system uses to decide which process gets access to the CPU at any given moment, ensuring efficient and fair resource allocation among multiple tasks. So actually here we have a CPU schedule when it is required means now we in system, it will be having only one processor and multiple processes are required to execute from that processor. When multiple processes comes for the execution, here the queuing between these processes it is required. That is particular schedule it is required among the competing processes. That queue, whatever it will be created by the operating system component, that is a scheduler, is called as a scheduling here. The scheduling is nothing but a queuing among the competing processes to allocate the processor in order to increase the efficiency as well as proper resource allocation. We have a scheduler. It will be scheduling the processes. So here we have a different types of the scheduling algorithms. Number of algorithms are there. Among those, we have a most important algorithms are the first come first serve, shortest job first, priority scheduling, and round robin. So here, before diving into these algorithms, we'll have a different criteria. Means now different algorithms, we are going to find out the efficiency. Each algorithm pros as well as cons, that how they will be implemented in the system. So in order to find out the efficiency of these algorithms, we will have a different criteria here. And these criteria are called as the scheduling criteria. So first one, we have a process ID. Suppose now we have a 5 processes that each process, it will be having its unique identity that is called as a process ID. For example, 5 processes are coming for the execution, then P1, P2, P3, P4, and P5 we can give. Otherwise, 1, 2, 3 numbering, any of the unique identity for each and every process which are competing for the processor. The next one is arrival time. So now n number of processes are coming for the execution. So how they will be arriving for the execution? Usually execution will takes in the critical section area in which the processor will be allocating for the executing process. So here at a time, all the processes are not coming here. If they are coming at a time, then we have to give the same time. Arrival time it is not given means all are coming in the initial position itself, that is the zero. Arrival time it will be 0 here. Otherwise, how processes are arriving for the execution, according to that sequence, that arrival time it will be given. Next one, it is a burst time. Burst time means for each process, how much time it will take for the completion of execution. Suppose now we have a P1. P1 is required 5 unit from the processor to complete its execution. P2, it is required some 8 units to complete the execution. Like that, in order to complete execution of that particular process, how much time it will be taking without waiting, without delayed. The next one, we have a completion time. Completion time means actually here we have a burst time. It is time required to complete for the particular process. But sometimes the process is required to wait. After by waiting and by continuing with the execution, total how much time it is taken to complete it. That its original required time, it will be different. And when it will be completing its execution, that time it will be different. It may be delayed because of the wait. Then next we have a this one completion time, it will be calculated with a Gantt chart. Yeah. Next one, we have a turnaround time. Turnaround time means here we have a actually completion time. Completion time it will be different from that of the burst time. Turnaround time, how it is calculated means completed time minus arrival time. Means at what time the process it is completed and at what time it is arrived, received for the execution in the processor. So here we have a arrival time minus completion time, that it will be giving the turnaround time. So turnaround time is nothing but how much extra time it will be waiting here, how much extra time it is taken for the execution, that it is calculated. Then next comes waiting time. Waiting time, it is a turnaround time minus burst time. Turnaround time, what it will give, extra how much time it will be waiting. That it will be given with the turnaround time here. And here we have a waiting. Waiting is nothing but a turnaround time. How much extra time it will be waiting minus that is the burst time. Actual execution time, how much it is, but completion time after by waiting when it is completed. That difference it will be calculated here. And next comes throughput. Throughput is nothing but a processor utilization. If any of the execution it will be using the processor for maximum extent, then it will be efficient. Otherwise, it is inefficient here. So it is not possible to use 100% of the processor utilization is not possible here. At least it should use more than 80, 85, 70 and all. So here we have how it will be using that throughput it will be giving more, then efficiency of the system it will be increases. Yeah. Then Gantt chart it is used to find the completed time, time completed to execute the particular process. That when it is completed its time, that it will be noted with the Gantt chart. Yeah. So here we have a different scheduling criteria. Process ID, unique identity of the process, and arrival time when process is arrived for the execution, like that multiple processes, and each process arriving time it will be noted here. And next one we have a burst time. Burst time means what is the actual time taken for the process to complete its execution. That for each process, maximum time, how much is required to complete its execution will be given with the burst time. The next one, we have a completion time. Completion time will be calculated with a Gantt chart. That is, when the particular process is completed, its execution, what is the time when it is completed with the execution, that will be noted in case of the completion time. Turnaround time it is including with the waiting time as well as burst time. Both it will be included here. That's what here we have a turnaround time is completed time minus arrival time. When it is arrived and when it is completed. That it will be shown. Here it is including with the waiting time also. Next one we have a waiting time. Waiting time is nothing but a turnaround time minus burst time. Means turnaround time, it is including the burst time as well as waiting time. So we need to separate the waiting time from the turnaround time means turnaround time minus burst time, it will be giving the waiting time here. And throughput is the maximum extent, how much, for how much extent the CPU it is utilized. Means here we have a processor time, it is very fast than that of the user execution time. That's what here we have a processor, it is very speed. For that speed, it has to go for the maximum task performance. So if it is using the maximum utility of the processor, it is there means it will be showing the high throughput. If it is a high throughput, it will be efficient here. So these are the different criterias. Then next we have to continue with the example here. And here the example is given. In the example, we have a total 5 processes and each process arrival time it is given. At what time the process it is arrived. And unique identity, process ID is a P1, P2 up to P5 it is. And arrival time 0, 1, 0, 2, 3 and all it is given. And burst time. Burst time means in order to complete P1, what is the maximum time is required? That is 6 unit. And like that P2, it will be completing its execution in 2 units. P3 in 1 unit and P4 in 9. And like that here, the maximum time required to complete the particular process. It is given here. Then here we are supposed to calculate the average turnaround time as well as average waiting time by using the different algorithms. First, we can start with the first come, first serve, FCFS here. So in FCFS algorithm, first thing what we have to do, given that process ID and arrival time as well as burst time. By using this, we have to go for the finding completion time. Here we are supposed to calculate the completion time. So completion time, how it is calculated? What is the formula for the completion time? Here, in order to find out the completion time, we have a Gantt chart. We have to put the Gantt chart and we have to go for the calculation of the completion time here. In order to calculate this one, just here, in this we have a first come first serve. The identity of the first come first serve is how processes are coming for the execution in the same sequence, the service it will be given by the processor. So processor, it will be executing the process in the same sequence. It is one of the non-preemptive algorithm. Non-preemptive means once it is started, any of the process it is started its execution, it will be executing for its fullest time for the execution, how much it is given. Fullest extent it will be executing. It cannot terminate in between and all. Now it is started from 0 and maximum time required is 6. After 6 only it will be giving its control to the next processor, next process for the execution. So now first come first serve, first come P1 it will be coming first here, and here arrival time it is 0. Usually in first come first serve, that arrival time we have to notice here how arrival time it is taken. According to that, we have to go for the services. First come, first serve it is. So first one, P1, it will be arriving at the unit 0. Maximum burst time it is 6. That's what in the Gantt chart, P1, 0 to how much time it will take? 6 unit it will be taking. So after this, we have a 2. That is P2 it will come. Arrival time of the P2 it is the 2. And its burst time it will be 2. 6 plus 2 it will be 8. So next P3, it will comes at the unit 3 and its burst time it is a 1, 8 plus 1, it will be 9 here. And like that only we have a P4. P4 it will be coming for the unit 4 and its burst time it will be 9 here. So 9 plus 9, it will be 18. Up to 18 unit, it will take the execution. Then last one we have a P5 with the unit 5 here. It is arrived at 5 unit and its burst time it will be 8. So here we have a 18 plus 8, it will be 26. So we have to write down the completed time for each and every process here. P1 is completed at 6 unit. I'll write the 6 unit here. And P2 is completed at 8 units. And P3 it is completed in the 9 unit. And P4 it is completed in 18 unit. And P5 it is completed in 26 unit. So here you can notice now the burst time as well as completion time. Now it is a 6 and 6. It is not waiting at all. And P2 it is completed at unit 8. But the time required for the P2 it is only 2 unit. But it will be waiting up to 6 unit until to complete that previous process. Here we have this difference we can notice that it will be calculated in the turnaround time. So turnaround time, what is the turnaround time here? Turnaround time is nothing but here completion time minus arrival time. That is turnaround time equals to turnaround time equals to here we have a equals to completion time minus arrival time. So now here we have a completion time, it is a 6. And what is the arrival time? It is a 0. 6 minus 0, it will be 6 here. 6 minus 0, it is 6. Then next we have a completion time 8, it is arrival time 2. 8 minus 2. This is equals to 6. Then next here we have a 9 minus, that is completed time 9 and arrival time it is a 3. This is equals to 6. Then next completed time is 18 minus arrival time it is 14. That is equals to 14. Then next here we have a completed time 26 minus arrival time it is 5. This is equals to 21. So this is the turnaround time which we are calculated here. Okay. After calculating the turnaround time, we can go for the waiting time here. What is the waiting time? Waiting time is equals to, so turnaround time, it is including the waiting time also. We need to separate that waiting time from the turnaround time. Turnaround time minus waiting time, it will give the waiting time itself. So, sorry, turnaround time minus burst time, that it will be giving the, means here turnaround time, it is including waiting as well as burst time. So only waiting I need to separate, means I have to go for the turnaround time minus burst time here. So now here we have a turnaround time, it is a 6. And what is the burst time? It is a 6 itself. So here it is not waiting. The processor is not waiting, that it will be 0 waiting time. Next one, we have a turnaround time, it is a 6 minus, here burst time, it will be 2. So here we have to go for 4. Then next we have a 6 turnaround time minus, here we have a burst time, it is a 1. That is equals to 5. And next turnaround time, it is 14 minus burst time, it is a 9. This is equals to 5. And next one, we have a turnaround time, it is 21 minus that burst time, it will be 8. So this is equals to 13 it is. Okay. So here we are calculated with the burst time. So this is in this chart, if you observe each and every process's status, you can get P1. What is the turnaround time of the P1? What is the completed waiting time of the P1? And what is the completion time of the P1? Like that, P2, P3, P4. What is the P5 completed time? What is the P5 turnaround time? And what is the P5 waiting time? So last one more calculation. If I need to calculate the average turnaround time and average waiting time, here I can go for sum of all these divided by total number of processes. This is equals to, here we have a 6 plus 6 plus 6 plus 14 plus 21. This divided by, it will be 5. Number of processes will be 5. This it will give the turnaround time. It will be calculating the turnaround time here. And like that, here we have a waiting time. Waiting time, that first process, it is not waiting at all. It will be started from the second. 4, it will be, second process, it will be waiting for 4 unit. And this one, it will be 5 unit, 5 unit. And last process, it will be waiting for the 13 unit. So here we have a waiting time, that is nothing but a 0 plus 4 plus 5 plus 5 plus 13 divided by 5 days. This is the average waiting time. We can calculate here by calculating these two. That here we have a 6 plus 6 follow 18 and 18 22 32 and 32 42 52 53 divided by 5. 53 divided by 5 means 10.6. This it will be taking 10.6 something here. Here it is equals to 10.6. And here we have a waiting time, that is 5 plus 5, 10, 23 and 27. 27 divided by 5 means it will be of the 2.12. This is equals to 2.12 something it will take. This is the waiting time and this is the turnaround time. So in one chart itself, we will have a complete calculation regarding the FCFS. Either you can go for the individual process or you can find out the average. This is how we can calculate uh, that efficiency of the first in, first out algorithm. So now The turnaround time, it will be taking this much, and waiting time this much. This we have to compare with the other algorithm, whether it is more efficient or less efficient to calculate. So next algorithm, we can continue in the next video. Till then, see you.